Okay. Yeah, so for those who might want to follow later, you can do that. I'll give the video. If it turns out to be too big, I'll just give you the link so that you watch it online. But then the thing we want to achieve looks like this. Allow me to run the game first. The thing we are seeking to achieve looks like this here. We want to have an opportunity to be bouncing something around as pipes pass through it. Just a minute. Okay, so there we go. We have an object. There it is. It is kind of, there are these pipes running across, and there's a second object that is supposed to dodge them. It keeps eluding me. Let's see. Okay. There it is. Okay, so there it is. There it is. So the whole idea is to have that object trying to dodge the pipes as the pipes pass through. There we go. Okay. Something like that. So the first object, the bouncing object, should be able to bounce across through the strokes of the spacebar. I'm hitting the spacebar to hit that object up, that one. Okay. There it is. So when it goes up like that, I'm hitting the spacebar. And then the whole idea is to have it manage to dodge the pipes. Dodge the pipes the way it is doing, and so on and so forth. So that's the thing, and I want to show us here how we arrived at it. It is the thing we tried to build last time, and then I had maximized this view here to a maximum. So the bird, I think last time we had a bird. This time around, I'm trying it with a ball. So the bird was, as soon as you clicked run, the bird was filling this whole area and therefore blocking any other view or any other object, and that complicated the ability of the game to run. So that's where we had challenges. So here we go. First of all, you need those objects. You need that bouncing ball. It's not exactly a typical shape of a ball, but they're online. I think there's at least one online tool that you can use to crop it in a rounded manner so that it looks like a real ball. So the ball is here and the pipe is here, right here. And these are pictures, like this one I've just downloaded, a picture of a ball. It was a typical ball. I kind of just cropped a small part of it. And then this is a picture of a pipe. which I've also cropped, right? So they're just your typical normal pictures you can download from wherever, or if you have in your computer, you can use. So 2 objects, you get them from wherever and you put them here as your assets, right? As your assets. And then you create corresponding objects to them. So there is the asset, and then there is the game object. Remember the way we create them here. It is 2D, it is 3D, it is an empty one. You can create a game object. So the game object is a programming idea within Unity to help you emulate the behavior of actual real life objects. You just like you can have let's say you are playing a game on your phone about football. The program that is written to help you or to help us play that game does not, cannot interact with a real human being or a real ball or a real field. It cannot do that. But we can get representations of a player or a field or whatever through pictures or videos. So these videos or pictures, we attach them to the object. So that is what we do here. When you right click and then click create empty, and then all of a sudden an object is now put here. This is an empty object. It is not tied, right? It is not tied to any real life thing. So the way to tie it, the way to attach it to any of these objects is what we were calling rendering. More specifically, you remember as creating a component here or adding a component that we were calling sprite renderer. Here it is. Okay. What it was doing is to help us associate this object with an idea or an abstraction that a game recognizes and a game can use. So that is why from here, we were dragging the object we want into here, right here, so that the game engine, you guys remember we discussed it and we agreed it has different parts. There are different parts of that engine. The graphics, the input, the output engine, and so on and so forth. So that engine can now use this object through the representation of this image here. So on the interface, you will see a ball bouncing or a pipe moving or somebody running. But to the game, what it recognizes is this. To the user, what it sees is the object that has been used, that picture, right? That picture. So how do you connect what is inbuilt with what you are bringing? You need to render it. You need sprite rendering. And that is why this property here is so important. Okay, so we can remove this. These components you can always remove if you want. Just click here and you remove. And we can also delete this object here. So the first thing we did, or you will need to do, is to make sure you have the right images where as your assets over here. And you can drag and drop them, or just right click and then click import new assets. And then you will navigate your computer and so on and so forth and get them. Okay, and then like I've shown you, you create respective objects for them, and through the sprite rendering property, you attach them. Okay, so there are things you will need, of course, depending on the function you want to imitate. For example, for purposes of that attachment and visibility, you will need to add a component called sprite renderer for purposes of collision. Okay, like now, when we were running this game here, you realize that whenever that ball hits a pipe, it is being pushed on the side. See that? It is being pushed on the side. That is to say, let me just repeat that for a moment. The reason why if that pipe hits the ball that way, it is not able to go through it, is because we gave it a property that is capable of imitating a physical object. So in real life, if a ball hits a pipe, the ball doesn't go through the pipe. Why? Because both of them are solids. They hit each other with an action force and a corresponding reaction force. So how do you ensure that this ball doesn't go through the pipe? We said you give it a property called a box collider. That's one thing you have to give if this is what you expect. That is one. You remember that that ball is always falling. It is always, the default direction for movement is down unless I press the space bar. If I press the space bar, it goes up. But if I don't press the space bar, it comes down. That property you give with something called rigid body. Under rigid body is where we were setting the gravity scale. You guys might remember. Okay, so you got to set that. So you set those ones depending on what you want to see. But there's something more, or there's something extra here that we also need to see. The pipes don't seem to be falling. They just keep moving across the screen. They don't seem to be falling. The reason why they are in that more or less constant level without falling is because they don't have the rigid body component. It was not set for them. Okay, it was set for the ball. That is why the ball is falling. But for these pipes, it wasn't set for them. So maybe if you want something to move or to stay somewhere constantly without responding to any physical forces, then don't give it rigid body properties. Okay, so that is that. Then, like I've said, this one, the one we are seeing here, is for the interface. It is for the user to see and interact with. But remember, all this work is being done by a program, and that program is written in these scripts you are seeing down here, in these scripts. So same thing, anytime you want to put a script to a component, you first select that object, and then you come over here and add a script, right, as a component. That's how it goes. You've got to have an object first, and then you can add a script. Like now, for example, this script is for the ball, this one. This other one is for the pipe, although now we have, as you remember, there's one pipe, but this one is a slightly different form of this pipe because now it has two of these. Okay, but this one is meant for this, and then this one is meant for the movement of this, the way they are moving across the screen. So anything you want to achieve through programming, please remember to create a a script for your object. Then so we've understood why the ball is falling. We've understood why the pipes seem to move constantly across the screen. It's because they don't have the rigid body property. Then we have one pipe here, but when the game runs, they seem to move across in pairs. Okay, there's an upper one and a lower one, an upper one and a lower one, like that, an upper one and a lower one. So the way we arrived at that is by creating this and using it to make a prefab. Like now, you guys know a table. A table. As you build a table, the top will be on its own. The legs or the stands will be on its own, and maybe the joints will be on their own. But you know, when they are alone, you can move them independently. You can like move the legs on their own or the top on its own and so on and so forth. But now once you nail the table together, then the legs are now tied to the top, which are now tied to the joint, and they move as a unit. Now, if such a unit is in such a way that it can help you to produce so many sample tables, then in game programming, we call it a prefab. A prefab. So this pair of pipes here are made from this. Initially, it was one pipe, but now it is a prefab of two of the same pipe. And what we did was very simple. What you're supposed to do is to create an object like now this, okay? Give it sprite rendering and drag this pipe to the sprite property. And then now you create children out of this. To create a child out of this, usually we just right click and then you say create empty. So when it appears in this way, it means this second object is the child of this first object. Okay, so think of this as an empty object, but think of this as this pipe here. So this pipe, we gave it two things. We gave it sprite rendering. Why? Because we want to attach it to this object, this image here. And then we gave it a collision property so that when it knocks the ball, it also doesn't go through the ball. Okay, over here. And then we duplicated it. If you do this for any object, if you right click and click duplicate for any object, usually you will produce the same object with the same properties. For example, if you gave this sprite rendering, the one you duplicate will have sprite rendering. If you gave this rigid body, the one you produce will have rigid body. If you gave this box collider, the one you produce will also have box collider. It's a duplicate. It's a photocopy. You are producing the same thing twice. So what you are seeing here, okay, this one, the top one, DOE. The second one is what looks like this. This one is the second one. Okay, so here we set sprite rendering, we set collision property, and then once we duplicate it, we are able to do that. And then now we set the script for the parent, because the parent is controlling them at the same time. All right. So I think I'm finished with the objects on the interface. Let's have a look at some coding. Let's have a look at some coding. So there are 3 scripts here, right? I have the first one, this one, I have the second one, this one, I have the third one, this one. Now, the first one, its job is very easy, okay? It is just bouncing the ball upwards. Last time I told you vector is about movement in a particular direction. So if you want to move your object to the left, you will find dot left. If you want to move it to the right, you will find dot right. We are moving our ball here to, upwards. That is why you are seeing dot up. And it is only moving upwards if we press the space bar. Get key down is like pressing the key. Which key? Space bar. Key code dot space is space bar. We have up arrow key or down arrow key or left arrow key or key N or B or C. You can use any key you want to give the users a chance to play your game. What is the strength of that bounce? Once you hit spacebar and the ball is moving upwards, with what strength is it moving backward? Do you want it to go so fast? You increase this value. Do you want it to go slowly? You reduce this value. So this variable is this one. Okay. You can see it doesn't have a value. Why? Because the value is being set on the game. The game environment. When you click the ball, you can see that variable here. And the variable is inside the script, so you can see we have the script component, and then among the attributes is that variable over there. All right, so there's that. So that really that's what it is doing. That's all there is. And then now this one is how you instantiate any component that you want to use in the code. For example, this one here is for the rigid body. For which object? The ball object. So when you check the ball object here, this one, it has rigid body 2D as a component. If you want box collider, you can do the same. If there's something you want to manipulate about its script, you can do the same. If there's something you want to manipulate about its transform, in other words, positioning, you can do the same. What about sprite? You do the same. In other words, these things you are setting here, you are also free to play around with them in the code. On which condition? That you instantiate. So think of this as a class and think of this as an object. So once you have an object, as you guys know, you can now access any property you want. For example, if I did see my rigid body, you can see it there. If you say dot, then there are so many things you can do, right? Why? Because there's now communication between the script and that component. So that is script number 1. Script number 2 is the one moving the pipes to the left. And by the way, I needed to mention that the reason why, if you just want the ball to bounce upwards once and stop, then this whole code, this one, you would put it here. Remember what we said? That the start method is executed only once. But this other one, if you want to have a repeated action, then you put it inside update. So thought I should mention that. So it is the same thing you're seeing here. The pipes are continuously moving where? To the left. Okay. They are moving to the left at a given speed. Which speed? 5 units, which you can also change on the interface because, you know, if you go to pipe here, let's see. If you click the spawn, it was on the individual pipe. The individual pipe was deleted after we created the prefab. Yeah. Once we got this, now this one ceased to be an object here. So that's why it's not there. But the pair of pipes are moving at a given speed, which you can increase or reduce. And then this is really not important, but it simply means that once the pipes have gone out of sight, if this pipe moves from here and goes and then it is out of sight, once they disappear, basically they have no use to us as they disappear like that. We are only interested in the ones we can see, but the ones that disappear, they have no use to us. So what's happening here is that we wait until they get to -45 on the x-axis, because they are moving on the x-axis. So we wait until they get to -45. Where is -45? Is what I approximated to be this point here. I don't know if let's see. Move. We are moving that object. Okay. Check here. Check here. I'm moving this one that way. What's the issue here? There we go. So continue checking that value. It's gone. Okay, so there we are, 45 there. So the argument is that by the time it hits -45 on this scale, it is out of sight, so we will lose nothing. There's nothing we will miss by failing to see it. So we are saying if it gets there, the pipes, they move. Okay, so they move. If they get over there, then we are destroying them. We are calling it a dead zone. There's nothing special, just a variable, but it is waiting until x dimension it at -45. Are you seeing that? And then after that, they are destroyed. Okay. And some message is displayed. That's the message you are seeing here. As it is here on the console. So as they disappear, you will see there we go. I've deleted. And they are being deleted so frequently, almost after every 2 seconds. So as soon as it disappears there, it is deleted. It is deleted. It is deleted. Why is the deletion important? Because these are objects. Remember, this is an object. Where is it? This one here. So if you don't destroy it, they will accumulate in the memory. And sooner or later, they will fill up that memory, and we don't want that to happen. So we clear them. So that's really it. Nothing special. So this code determines which direction the pipes are moving and at what speed they are moving. And I mentioned to you guys last time that this delta time property is just a way to ensure that we have constant movement or display movement on whatever screen you have. Right now, I'm using my laptop. What happens if you run this game on your phone? What happens if somebody runs it on their TV screen? Those different screen sizes should not affect the rate at which those pipes are moving. So that moderation is done by this variable here, okay? The amount of time they need to move from one end of the screen to the other needs to be constant, and that's what we are trying to do over there. Then finally is the third script, and the major role of this is to spawn. It is the one responsible for this. It is the one responsible for the production of these prefabs. You see, they are coming from here in a continuous stream, a stream that never ends. And each time a pair of them is created, we get this message here. I'm sure you've been seeing it, this one. It's not even a message, it's actually a prefab created. Okay, so every time it creates this, we are updated here. Here's that, we are updated. Here's that. So this one, I didn't do. This one is something Unity has in itself by default. Okay, and it is what you are seeing here in this script. Whenever you say instantiate, okay, it is like you are telling Unity to produce something. Okay, produce another instance. If you want to produce another object, you tell it to instantiate. So in our case, we are producing a prefab called pipe. There it is. We want to keep producing them. And as they are produced, we want them to be moving along the X direction. And then we want them to be changing the Y positions. Yeah. That's why you are seeing this. You see the first pipe is here, but you can see it is slightly higher than this. Yingine slightly lower than this. This one slightly higher, lower, higher, lower, higher, lower, much lower, lower. This is higher than it. This is slightly higher than it. So it is like, it is doing like this. Some of them come same level. Why? Because it is random. Okay. But that random positioning is controlled by two variables here. We have the lowest it can ever go towards the lower side of the screen. Are you seeing it? Okay. So the Y position the pipe can drop towards the sorry, along the y-axis. But every time it drops, there's a constant figure we are subtracting from it. Okay, this one. Subtracting 10 units from it. So if it goes up, we are adding 10 minutes from it. From where? From the origin, from the x-axis. So that is why you can see them appearing at different levels. The z-axis is remaining the same. The third dimension is remaining the same. Why? Because our game, remember, I don't know whether you remember, we started it as a 2D game last time. So Z position is remaining the same. And then the rotation is also 0 because we are moving constantly horizontally. There's no rotation. So if you check properly, this thing has been put in a method, just like the update is a method and just like start is a method. So the reason why it is in a method is because we want to do it over and over again. So we could take the whole of this code here and put it here. But now maybe to appear clean or something, here now we are simply calling the method to repeat that same thing for us. So please also note that as soon as this method has been called, in other words, once we have a pipe set and a pipe moved successfully to the destruction point, the timer is set to 0. Which timer? The same one controlling the harmonization on the screen. It is set to 0. Why is it set to 0? So that we can start again as we create the pipes. Okay. So span rate is the rate at which the pipes are being produced, and then the timer controls how long they are on the screen vis-a-vis the standard screen time. So guys, this is the code I want you to use to create your own assignment, and your own assignment will look like this. The only thing you will change for me is the objects, right? The objects here, I've tried to use a ball and pipes. Please don't use balls and pipes. Or if you must use a ball that is round. Mine seems to be square. And so you are free to use what? You are free to use two animals, you know. One animal is the prey, the other is the predator, and the predator is chasing the prey, and if it catches it, the game ends, and so on and so forth. You can use a vehicle and road bumps. You see if it can navigate them successfully. You can use a capsule that collects coins. That's a very common example in game programming tutorials. You can use it, no problem. Okay, you can use a train trying to successfully pass through some barriers, and so on and so forth. Whatever you will like or you would want to use, just give me two objects, and one object will be dodging another, and both of them will be in motion. That is one. Number two thing that you will do in that assignment is that you will provide a reward scheme. Okay. For example, unfortunately, my game is running infinitely. but you can put a timer component even within the update method to count the time. Okay. So for example, if the game runs for if the game runs for 5 minutes and I have successfully dodged the pipes, each pipe I dodge, maybe you can put it that way, each pipe I dodge, I earn points. Okay. Each pipe I dodge, I earn points. If you are a vehicle with bumps, each bump you dodge, you earn points. If it is a capsule collecting coins, each barrier you dodge and collect coins successfully, you earn points. Such that if the game ends successfully with maximum points, we celebrate. If a mistake happens, like in my case, if a pipe knocks me down, then the game ends so that I can start again. I don't know whether you guys understand that. Mnaelewa? You know, just the normal thing. It's a game and points are earned based on the successful completion of the game trick. So you choose your own objects. Do not let them be pipes like mine. Just choose your own pair of objects and produce something that earns points. If a mistake is made, the game stops. If you run all the way, if you run all the way to the end of the game successfully, we celebrate the points that have been acquired. So this is the source of the assignment. Okay, so for now, I'll switch to the scripting bit. And let me close this. I can. And even this minutes. Yeah, so very briefly, all I want to show you is a bit of getting started with the scripts. So I'll have an object here, and there's nothing special to it. What I want to add is just a script. There you go. Call it script 1. Just want to emphasize a few things. And now that we will all be in campus doing the cut, I think we can mark the assignments on that same day. That is going to be next week on Tuesday. I think that would also be a good idea. You know, online things come with lots of challenges. So I'll try my best to get a fairly spacious hall for the assignment, sorry, for the cut. And then after, as soon as we've done the cut, that's also the same venue where we'll mark the assignment, the one we've just given. It would be easier that way. Okay, so the first thing that we need to know is that this thing is probably easier than any other programming you've ever done. There are some basics that remain constant. For example, this would be your area to declare global variables. For example, if I say public int number, and I say public string str, typical stuff where you declare your variable. The only difference is that it comes with this benefit to enable us to run something once and also to run something as many times as we want. And by the way, you are free to get rid of these methods here and do your own specific things from scratch. Okay. But then now, if I say number is 10 and string is KCA, normal stuff. Now watch this. I can go to the game and run it. You're running the game. Our object, in this case, it's a sphere hanging there dangerously. Ordinarily, this script here should give us or show us the variables that it has. But currently, you are not seeing any of them. They're not there. Because you see, if we wanted to change the value of number or the value of that string when the game is running, we would not be able to change it. So the thing that we've forgotten to do is to attach this script to the engine So it is like the unit engine. So it is like the unit engine still doesn't know it. So anytime you create a script, please remember to attach it. Okay. Remember to attach it like this. You can also achieve the same by just saving it. File, save will also do the trick, but it is so important that you attach it. So we can display now the value of number, and by the this is how you display direct output. Usually we say log, so debug.log does that for us. The value of number is, then we probably want to concatenate it with the number that way. Yeah, so this is going to run only once. But remember, because we've made changes, now you have to touch it. You have to attach it. So once you attach it, as you run the game, this side, as you run the game, this side, you should now see under script, your variables are being recognized. They're here, so you can change them as you want. That is one. Number two, our output is usually, you will usually see it under console. There it is. So don't look for text output anywhere else. Here it is. This is where you find it. And you can change the value of that variable here. Yeah. Just edit it here, whether you want to edit this and this. Run the game again. And it will be reflected. Sorry, you need to edit it when the game has stopped. Just a minute. And do the edit right here. And then run the game. Okay. So it is picked here at runtime. Okay. So please remember that the script and rather the variables in the script will always show up here within the script component, and you can therefore manipulate them right there. So that's one. Number two, please remember that whatever you want to do only once, put it here. Whatever you want to do numerous times, put it here. Okay, like now this will display that line so many times, infinitely actually. Yeah. So it will display the first one here, but thereafter every second. Okay, also display every second. You can see the count here. Sorry, it's not every second. It's, you remember the frame definition, 60 times per second, 60 times per second. That's what we are seeing here. When 1 second goes, we add 60 here. So anything you want to do continuous, and that is why it works very nice in this engine because what is called a game is images moving continuously. We give them motion and then we allow them to run without stopping. There you go. So that's the count. Yes, there are guys who are not. Okay. So the other thing is just the usual advice in programming classes. It is always a good thing to write or organize your program in form of methods, especially if it is getting a bit big. We are usually encouraged to write it in what? In methods. So here is very simple. Apart from once you have this class, okay, you are free to put your method down here for purposes of order. So I can say public int add. I'm just creating a method of my own here. And I want to say return 0 for now. Remove that error. No, I don't even need to return 0. Let's just go straight to it. Return 6 plus 7. So this will return. Yeah. So I can display that feedback here. Debug.log. And then in here, you can call that function. Method output is so it will be called, the method will be called right here, and I will see that text preceding it. And of course, in this case, it will be called only once. Okay, so as usual, you must attach it before you to run the game over there. So there it is. 6 plus 7 should be 13. So there's nothing strange here or unusual. It is the same skills that you have. So when we ask you to write a script, okay, it would be good to have the templates in mind, the name of the script, importing from monobehavior class, and then you create the body and you make sure you close the body. If you are required to put something in the start method, please do so. If you are required to put something on the update method, put it accordingly. If you are required to write your own method, this is where you need to put it. But the basic things of declaring variables and using loops and writing methods and dealing with arrays or array lists or whatever data structure you want to handle, they're the same. They're the same. So we will be doing this on the go. Why? Because our unity is learned here. Okay, we put objects here, and then they tell us, or they influence us on what to put on the code, not the other way around. Right. So get bold, get used to it, and try things out. So I would want to let you go at that point. I'll post the code on WhatsApp in a moment. And I think we can now meet on Tuesday, then, as we do the cut and mark the assignment. Unless there's a question, I think now our class can end at this point.
Excuse me.
Go ahead, Eugene.
What will be the scope of the cut?
Within what has been learned.
Okay,
that's the scope. Right. So we can stop the recording.